Hello guys, this is Friday Academia. Today we'll be looking at the argument of a complex number. Now the argument can be defined as the angle line OZ makes with our positive x-axis. Okay, so this is a picture of an Argand diagram. So we are looking at the angle that line OZ makes with our positive x-axis. This is our x-axis, but this side is for the negative values of x. But we are trying to find out the angle that line OZ makes with our positive x-axis. Now for us to do that, I want to show you there are 4 quadrants of an Argand diagram. So I'll be showing you how to get the argument for each case. Alright, so for the first quadrant which you are seeing now, this is our first quadrant. Okay, at this point, the value of our angle is called theta. Okay, so the formula is theta, right? So I'll be showing you how to derive formulas where you can use in calculating your argument. Now for our first quadrant, assuming here opposite sides are equal, so we can also call here y, and here is x, and this is theta. Okay, now in our secondary school we've done something called the SOHCAHTOA. Please don't forget, this is SOHCAHTOA, right? Now the formula that fits into this, we only have our opposites, we have our adjacents, we don't really have our hypotenuse. So everything that has to do with hypotenuse, we can't use them. So we'll be using our tan, and our tan formula says that tan theta is equal to the opposite over the adjacent. Okay, we have our opposite and we have our adjacent. So tan theta is opposite over adjacent. The opposite is y and the adjacent is x. Okay, so but we are asked to look for theta, not tan theta. So we'll be dividing both sides by tan. Alright, so now the tan will cancel tan and our theta will give us this, or you can also call it the tan inverse of y over x. Alright, so this is our value for theta. Now when we have our theta in the second quadrant, there are cases where your x will be negative while your y remain positive. This is our second quadrant. Now at this case, theta will be appearing here. But like I told you, our argument, the emphasis is on the angle made with the positive x-axis, not this one, with the positive x-axis. So now at this point, we'll be calculating, we want to find out what the value of this angle is, even though theta is appearing at this point. Now if you look at this line x, very critically, you will see this is a straight line. An angle on a straight line sum up to 180 degrees. So to find the value of this side, we'll be subtracting theta from 180 degrees. So for our second quadrant, our formula will be 180 minus theta. And theta is what? The tan inverse of y over x. So this is our formula for finding our argument in the second quadrant. Now let's go to the third quadrant. This is our third quadrant. We are working anti-clockwise. First quadrant, second quadrant, third quadrant. Now this is our third quadrant. And usually in our third quadrant, theta appears at this point. Please note the point I'm trying to get my theta. Theta appears at this point. So to find our argument, like I said, is the angle that is made with the positive x-axis. The angle made with the positive x-axis, okay? So we are looking at how to get all the value here. Now this is a straight line like we just said, and then theta is adding to it. So to get this angle at the third quadrant, we'll be adding the value of theta to 180 degrees. So we can get all this, okay? So for the third quadrant, we can say that theta, or our argument is equal to 180 degrees plus the value of theta. And I said our theta is equal to what? The tan inverse of y over x. Now let's move to the fourth quadrant. Now our fourth quadrant is at this point. And at this point, our theta usually appears here. Okay, theta appears here. Now, like I said, our argument means the angle that is formed with a positive x-axis. This is our positive x-axis. So every angle must be traced back to this point. But theta is appearing here. Now, if you look critically, there's something called the angles at a point. The sum of angles at a point is equal to 360 degrees. Sum of angles at a point is 360 degrees. So to get the value of our argument, we'll be subtracting the value of theta from 360 degrees so that we can get this place. So for our fourth quadrant, our argument is equal to 360 degrees minus theta. And our theta, like I said, is equal to what? The tan inverse of y over x. Are we together? So with this, we'll be taking examples and we'll be trying to see how we can derive argument at each point. Please stay with us. Okay, so given that z is equal to 3 plus 2i, and we are asked to find the argument of this value, of this complex number, the first thing we need to do here is to plot our argon diagram. And in plotting argon diagram, you must know your x and y. So our x from here is equal to 3, and our y is equal to plus 2. Okay, so I'll use that to form my argon diagram very quickly. Please ensure, like I said, you have a perfect work. Our x is positive 3 and our y is equal to plus 2. So the point where they meet is where our line OZ is formed. So this is our line OZ, and the value here is z is equal to 3 plus 2i. But we are not just asked to find the argon diagram. We are asked to find the argument. Our theta is at this point. We are asked to find the argument. And since this is the first quadrant, if you are with us in our diagram, this is our first quadrant. So we'll be using the formula for the first quadrant to determine our argument. And the formula states that our argument is equal to the tan inverse of y over x. So quickly we'll be doing that. The tan inverse, and our y is plus 2, and our x is 3. Okay? So that's the tan inverse of approximately 0.67, and the tan inverse of 0.67 that will give us 33.82 degrees. Okay, or you can say approximately 33.8 degrees. So this is it. This is our value. This is our argument at the first quadrant for theta. So let's take another example quickly. Now let's assume that we are given that z is equal to minus 3 plus 4i, and we are asked to find the argument for this complex number. Like I said, the first thing you do is to plot your argon diagram, and in doing that, we must know the value of our x, minus 3, and our y, which is what? Plus 4. With this, we can plot an argon diagram to know whether it is on the first, second, third, or fourth quadrant, because that will be determine the formula we'll be using to solve it. Alright, so our x is minus 3. Negative x is at this point. So x is minus 3. And our y is positive 4. So this is our line OZ. Okay? If you can see, this is on the second quadrant. This is on the second quadrant. So we'll be using the formula for calculating the argument on the second quadrant, which is 180 minus tan inverse of x over y. So we'll do that quickly. So our argument will be equal to 180 minus the tan inverse of our y here is 4 and our x is minus 3. Okay, before I do this, let me explain something quickly. In calculating our arguments, we are using absolute values. Now, even though our x is having a minus sign, we will not be including the minus sign here because we are using absolute values. So it will be 4 over 3, no longer minus 3, because we are using absolute values. So this is it. So we will be calculating this now, which is 180 degrees minus the tan inverse 4 over 3 will give us 1.33. So we are finding the tan inverse of 1.33, which is equal to 180 degree minus 53.06 degrees. Okay? So our argument for this point is equal to 126.94 approximately. This is our argument on the second quadrant. So we take 2 more examples and then we are done. Now at this third point, let's assume that our z is equal to minus 5 minus 4i. Okay? And we are asked to determine the argument of this complex number. So now, like I said, the first thing we do is to get our Argand diagram, and which we have to know the value of x and y. So our x here is equal to minus 5, and our y is equal to minus 4. They are both negative. So we can plot our Argand diagram now. This is our x, this is our y. Now x is negative, so it will be on this point, minus 5. And our y also is negative, so it will be here, minus 4. Okay? So we trace it. I'm just giving a rough sketch to get our line OZ. Now if you watch this is the first quadrant. Like I said, we are moving anti-clockwise. This is the first quadrant, the second quadrant. So our line OZ appears on the third quadrant. That means we'll be using the formula for the third quadrant to calculate our argument. And the formula states that our argument is equal to 180 degrees plus the tan inverse of y over x. So we'll be doing that here. I told you something that we'll be using absolute values, meaning there will be no negative sign. So when we get there now, our argument is 180 degrees plus the tan inverse of y over x. 180 degrees plus the tan inverse. Our y here is minus 4, but the absolute value is 4. And our x is minus 5, but the absolute value is 5. Absolute means the number without any sign. So we are here, which will give us 180 degrees plus the tan inverse. Now 4 over 5 will give us 0.8, if I'm not mistaken. Okay, so 0.8. So we'll be finding the tan inverse of 0.8. So that will be 180 degrees plus 36.66 degrees. Okay? Okay, sorry, 38. 38.66 degree approximately. So we'll be adding that to 180 to get the argument, which will be equal to 218.66 degrees approximately to 2 decimal places. So these are our arguments when this is on the third quadrant. So this will give us, this is our argument. That means from the value for this, the value of the argument here to line OZ is equal to 218.66 degrees. One more example quickly. Now, given that our z is equal to, let's say, 4 minus 3i. Okay, this is our z. Our z is equal to 4 minus 3i, and we are asked to find the arguments. The first thing we do is to identify our x, which is equal to 4, and our y, which is equal to minus 3. Then with this, we can get our Argand diagram. The Argand diagram helps us to know whether our OZ is on the first, second, third, or fourth quadrant. So let's form our Argand diagram quickly. This is y, this is our x. Now, x is positive, meaning it's to be on this side, 4, and our y is negative, meaning to be down, 3. Okay? This is our line OZ. Now this is our first, second, third, fourth quadrant. So that means OZ is on the fourth quadrant. We'll be using the formula for calculating the fourth quadrant, which is equal to 360 degrees minus the tan inverse of y over x. Okay? To get this is our argument. So let's solve quickly. Our argument is 360 degrees minus the tan inverse. Our y is minus 3. We are using our absolute, so that's 3 over, and our x is 4. Okay, so 360 degrees minus the tan inverse of 0.75. Now the tan inverse of 0.75 will give us 36.87 approximately 87 degrees. So our argument at this point will give us 323. And that's our argument. So we've come to the end of arguments in our complex numbers. So please do well to like this channel, give us your comments, how do you see our videos, and don't forget to subscribe, and also click on our notification buttons so that when new videos are released, you'll be notified immediately. See you next time. Thank you.